we're going to learn how to draw and name aromatic compounds containing benzene. You can see here that we're representing benzene in two ways. In the first example, what we have is our 6-carbon ring structure with the alternating double bonds, and that would be in a structural diagram. Next to it, we have a line diagram representing benzene, again with our 6-carbon ring structure, and the circle in the middle is meant to represent the alternating double bond structure or resonance within the molecule. Some interesting molecules to be aware of. One is toluene, that's its common name. The IUPAC name is methylbenzene. This is used in industrial applications, and the presence of the methyl on the benzene makes that compound less harmful than benzene. Both are used as industrial solvents. Next to it, we have naphthalene, used in mothballs. Interesting to see the two benzenes stuck together like that. And then we have vanillin, which gives vanilla its characteristic taste and scent. And then we have phenol in the bottom, often used in things like pharmaceuticals as a starting molecule to manufacture other molecules. The IUPAC name for phenol is hydroxybenzene. So when we name aromatic compounds, what we do is when we start out with a mono-substituted benzene, mono-substituted meaning there's one side group on the benzene, we add the name as a prefix to benzene. In the first example, we have chlorobenzene with a chlorine atom attached to a benzene ring. In the next one, we have a nitrobenzene with the nitro group. But what if we have two side groups that are identical? If we do, in the first example, we have a 1,2-dichlorobenzene. When we are numbering our carbons in our main chain, and that would be the benzene ring, we are trying to give the two chloro side groups the lowest possible numbers. So we number them 1 and 2. The other way of naming that is O-dichlorobenzene. The way I remember that is I think your teeth are nice and straight and side by side when you go to the orthodontist. The O stands for ortho. In the next example, we have a 1,3-dichlorobenzene, again numbering to give those chloros the lowest possible number. And then the other way of naming it is M-dichlorobenzene. M stands for meta. I remember that as M for missed one. In our next example then, we have a 1,4-dichlorobenzene, also named as P-dichlorobenzene. P stands for para. What I think of is parallel, that they're opposite each other. Doesn't quite work, but it helps me to remember it. When you have more than two or different side groups, we may not use our OMP method for naming. Instead, we're going to go back to just using numbers. And in this example, we have a 1,3-dibromo 5-chlorobenzene. Now, the question in this example is who gets the lowest number? The convention with halogens attached to a base chain is to give the heaviest atom the lowest number. So if you can think of in your mind, or if you can see a periodic table, you would notice that bromine is down towards the bottom, chlorine up towards the top. We know that the heavier atoms live towards the bottom of the periodic table. Therefore, our bromos are going to be 1 and 3, taking priority over the chloro, which is at the number 5 position. So back again to the reason or what the O and the M and the P represent, ortho, meta, para, and I remember them as side by side at the orthodontist, M for missed one, and P for parallel. Now, what if you get some different side groups and you're trying to figure out which one should have the lowest number? I should tell you that in many cases you need to look these up to figure them out, but there are some generalities that we can apply. So in this example, we're going to give the lowest number to the largest substituent. So we have a cyclopropyl with 3 carbons and we have an ethyl with only 2, and therefore we're going to give the larger group, the cyclopropyl, the number 1, and then we're going to number down and to the left so that our ethyl can be at the number 3 position. Notice when we name it, we put the ethyl at the front and we count the propyl. We're comparing alphabetically the ethyl to the propyl. The cyclo does not factor into it. So we can also assign numbering according to alphabetical order, again, except where the halogens are concerned. Another example of that is sketched on the left over here, where we have the iodo at the number 1 position and the chloro at the number 3. So iodo, of course, is towards the bottom of the table, a heavier element, and therefore taking numbering priority with the lower number. I have crossed out here the O-bromo chlorobenzene. I'm hoping you can see that. I put it there on purpose so you can see that that's a do not do. That's why it's crossed out. In our next example, we have something that you probably recognize as TNT, trinitrotoluene. And in this situation here, we're actually going to call our methyl group number 1. The reason for that is methylbenzene is known as toluene, and therefore that methyl group gives that structure its identity as toluene. Therefore, the methyl will be number 1, and then we can number away from that to put our nitro groups at the 2, 4, and 6 positions. Notice again alphabetically, the methyl comes before the nitro. The tri is not considered when we're positioning the names. Now, benzene groups can also be side groups on a longer, more complex chain. So now we're going to look at how to name them. In our first example, we have 2 benzene rings attached to 1 carbon atom. In that case, we could name this as diphenylmethane. And so benzene as a side group is called phenyl. Over to the right, we see phenyl attached to an R group. An R group is any old carbon chain. We're not concerned about its identity right now. We just want to note that phenyl is a side group coming off of a longer, more complex carbon chain, and therefore it's named as phenyl and not called the carbon backbone, benzene. Sometimes the side group benzene comes off with another carbon between it and the base chain. In the first example here, to keep things simple, I've given you the molecule benzyl bromide. We're calling our base chain bromine, and then we're naming the side group with the benzene attached to the CH2 as benzyl. You'll notice to the right then that we have benzyl attached to an R group. Again, the R group is any old carbon chain. It's sometimes difficult to distinguish between the 2 groups, the phenyl and the benzyl, and one would be more inclined to call phenyl benzyl because it looks more like the typical benzene. This is a tricky thing that you'll need to write down and you'll need to commit to memory to separate the two, that phenyl is just a benzene side group, benzyl has an additional carbon in between.